this video, we shall discuss about radicals. We need to discuss radicals to give meaning to rational exponents. Like if we have powers of the form p by q, which are rational numbers. So what does it mean if a number has a rational number as a power? So to understand all these concepts, we need to study radicals. Before we start, I will explain certain notations. We all know that this notation represents square root, and this notation where we have an n over here, this represents nth root of a number. So we shall define what is a square root now. Suppose we write square root of a is equal to b. What does this actually mean? This implies if we multiply b twice, we will get a. So if you are asked to find out the value of square root of a, it means to find out that number b which when squared will give us a back. So this, and here b is always greater than or equal to 0. So this is said to be principal square root or just square root. You can say, for example, consider square root of 25, which is the number when multiplied twice or raised to the power of 2 will give you 25. That is 5. Therefore, square root of 25 is 5. You can also say that it is your minus 5 the whole square also gives you 25. But according to the definition, if you are finding principal square root, b always has to be greater than or equal to 0. To get negative 5, you should apply negative of root 25. Then you will get negative 5. Now we shall define nth root of nth principal root as well. So that is principal nth root. So if n is any positive integer, then principal nth root of a is denoted by nth root of a is equal to b. That implies, as we defined in the square root, it is same as raising b to the power of n will give you a. So note, this is an important note. So if n is even, we have a always to be greater than or equal to 0 and also b to be greater than or equal to 0. So here we have and, that means these two statements have to be true all the time. So why a should always be greater than or equal to 0? Because negative nth roots of numbers are not defined as long as we are working with real numbers. We will learn more about this when we study complex numbers, which is not part of this course. So suppose, and why this b greater than or equal to 0 should be true. Suppose a is negative and we have, say, n even, say n to be 2, for example, and we need to find out square root of negative a. So you cannot, to get a negative number, you should be applying a power to some negative number only. So you cannot raise negative b to the power of 2, and that never fetches you a, negative a. Why? Because the power is also for the negative sign, and a negative sign raised multiplied even number of times gives you a negative sign, not a positive sign, not a negative sign. So these two have to be true always. So all these nuances in a definition or the restrictions and every part of the definition is very important. So to pay attention to all these nuances, here is a quiz, which is 1.1.4. Say true or false. And explain your answer. So the statement goes like this: for all, this symbol represents for all. For all a belonging to R, that is a is a real number, if a power m is equal to a to the power of n, a to the power of n, so then m is equal to n. So check whether this is true or false, and you should explain your answer. That is, you are given this statement. That means you have this as a data and you should prove this and say whether this is true or false and explain. So before going into the properties of nth roots, I would like to give you a definition of nth root as a rational exponent. Nth root as a rational exponent. So we have seen that we denote nth root of a number a like this. So this can be written as a to the power of 1 by n. This is very useful in proving the properties of nth roots. So now we shall study properties of, or you can say to be rules, nth roots. First one, suppose I consider nth root of AB. So this is the product of two numbers a and b. So the nth root can be distributed to each term. This is equal to nth root of a times nth root of b. So to prove this, I consider LHS nth root of AB. So this, applying the definition here, can be represented as power of rational exponent like a to the power of b whole power 1 by n. But by the rules of exponents, we know that this power can be distributed to both a and b. So this will be a to the power of 1 by n times b to the power of 1 by n. And this individually, again applying the definition above, this is nothing but nth root of a times nth root of b. So this definition of representing nth root in terms of rational exponents comes very handy while proving stuff like this. So I will give you an example. Suppose I consider 4th root of 16 times 81. So I should verify each side of the equation first and check whether I am getting the same answer if I operate it like in the method given in LHS and method given in RHS separately. So this would be nothing but 4th root of 1296,096. So that is nothing but 6. So now I will apply this method, that is our RHS method. So that would be 4th root of 16 times 4th root of 81. So 4th root of 16 which is a number that when raised to the power of 4 gives you 16. That would be 2. And which is the number when raised to the power of 4 gives you 81. That is 3. So 2 times 3 is 6. Kindly ignore the thunder sound. It's raining very heavily outside. Okay, so that means we have the LHS and RHS to be equal and the first property is true. So now we will prove we will state the second property, that is square root of n for a over b. Again here, as we did above, we can distribute the square root of nth root to a, that is numerator, as well as for the denominator. So this again you can prove it as I have shown you here, using the definition of nth root being expressed as a power of rational exponent, as well as using rules of exponents. So I will give you an example. I am not going to solve it as I did in this step. I am just going to write how we are going to apply this. So suppose I consider 4th root of 16 over 81. So again, so this would give us 4th root of, by applying this rule, over 4th root of 81. So that would be 2 over 3. Third property, suppose I consider mth root, m for monkey, root of nth root of a. So this is nothing but m nth root of a. So to prove this, I can write the term inside, that is nth root of a, as mth root of a to the power of 1 by n, and this mth root, as again using the definition, I can apply the power of this over this. So then using the rules of exponents, we can multiply them, a to the power of mn. So now you may be wondering how nm became mn, because real numbers satisfy commutative property under multiplication. Nm is equal to mn, so it doesn't matter. So this can be written again using the definition. It is the mnth root of a. So for example again, suppose I consider cube root of square root of 729. So this is nothing but 1 by 2, and this is nothing but 1 by 3, or 2 and 3. So you can write this as 6th root of 729. So that is nothing but 3. Now going to the next property, number 4. It states that nth root of a power n is equal to a if n is odd. So you should pay attention to this. The fourth property and the fifth property have the restriction over n. So I will give you example so that you can understand the difference between both of them. To prove this, before giving an example, I can write this as a power n whole power 1 by n and multiply them using rules of exponents, and this would be a. You may wonder what is the role of n here. So I will give you an example considering a to be a negative number for better analysis. So I consider a to be negative 5. So apply cube root for negative 5, whole cube, sorry. So n and n are same. So this means that the cube root is for negative sign as well. Therefore, the negative sign will be multiplied odd number of times, that is 3 times, and that will give you a negative sign only. So that would be minus 5 whole to the power of 3, and this would be 1 by 3, right? So that would, if you multiply this, you will get back negative 5. So you are considering a to be negative 5, and when you apply the property, you are getting negative 5 itself. So what is the difference? When will this be different for different n? That would give you property number 5. That is a to the power of n whole to the power of 1 by n. So this would be absolute value of a if n is even. So yeah, I'm sorry, I should have written this as nth root doesn't matter. Okay, nth root of square root of a to the power of n, a to the power of n will give you absolute value of a if n is even. So again, considering the negative value of a, we can see why it is important that it be absolute value because of the sign. Suppose I consider a to be minus 2 and consider n to be some even number 4, say. So then what happens? You will be considering fourth root of negative 2 whole to the power of 4. So this even now you are multiplying the sign even number of times, the negative sign even number of times, you will get a positive number. So applying the property number 5, you will get back 2. So that is nothing but absolute value of negative 2. Moving on further, all radicals are real numbers. Therefore, they obey all properties of real numbers like associative, commutative and distributive properties that we discussed in our review video. So we shall use all these properties as well as the rules of the nth roots as well as the rules of the exponents and combine and simplify certain radical expressions involving radicals. So combining radicals simplify the expressions. I'll be doing some exercise problems which are not assigned even as a quiz or as a homework, and I may even do some different kinds of problems as well. So first one, I consider square root of x square times y to the power of 4. So using the first property of nth root, I can write this as I can distribute the nth root to x term as well as to the y term. So this will be square root of x square times square root of y to the power of 4. So this is because this has property you can apply property number 5 where n is even, therefore this would be absolute value of x, and here which is the number which you multiply twice and gives you y to the power of 4. This is a perfect square, so that is y square. So y square times absolute value of x is the answer. Next, second one, I'll take a different tougher example wherein we can apply maximum number of properties of everything like exponents as well as real numbers as well as nth roots. So consider this: 4 times 18r square root of 18r r t cube, which is equal to plus 5 times 32 r cube t to the power of 5. So now to apply property number 1 of nth roots, the terms inside the square root can be split as if I can apply square root directly for perfect squares and I can take it out of the root. So I am going to factorize in such a way. 18 can be written as 9 2, where 9 is a perfect square, r, and t cube has t square to be a perfect square and t, plus 5. Here 32 has a 16 that is a perfect square and 2, and r cube has r square that is a perfect square and r, and t to the power of 5 has t power 4 times t. This is a perfect square again. So now you need to pay attention. You can apply property number 1 to this, but never, I will write it as a note, but never do this mistake this is never equal to square root of a plus square root of b. Because if I consider 9 plus 16, 9 plus 7, so that would give us square root of 16. But if I individually apply square root of 9 plus square root of 7, so that will give us 3 plus 2.64 something approximately. So this would be approximately 5.64 something. This is square root of 16 is 4. So 4 is never equal to 5.64 something. So this is never true. You can distribute the roots, nth roots, only if it is a product, not for addition, not for subtraction, and you can do it for division as well. So I will name this as star. So now star will be equal to, taking perfect square, 9 is a perfect square, so 4 times, before that I shall, for better working, I shall split the terms, apply property number 1 to each of the terms above in star. So 16 2RT. I have put all the terms which cannot be reduced, which are not perfect squares, into one roof, and this would be square root of r square times square root of t power 4. So now we can simplify it further. Square root of 9 is 3, and this would be 2RT. And here you can see that n's value is 2, which is even. So you can apply property number 5 here. So that would give us absolute value of t plus 5 times square root of 16 is 4 times square root of 2RT. You retain it as it is, and this will be, this is an perfect square. Therefore again, we do not know whether r is, we know that n is even. So therefore this would be absolute value of r times, this is a perfect square, t square. So let us simplify it. So this would reduce to, before that we know that real numbers satisfy distributive property. So here the distributive property of real numbers comes handy. You can take things that are common outside and group things that are not common. So you have 4 to be common and a square root of 2RT to be common. So I will take it out, applying the distributive law of real numbers, where multiplication is distributed over addition. So this would be 3 times absolute value of t plus 5 times absolute value of r t square. So this so we have used maximum properties of all that we have learned so far in this problem, and this step is by applying distributive property of real numbers. I will go for another example where I will simplify the expression and eliminate negative exponents. This is same as exercise number 76 in your book. So I consider 5th root of x cube y square times 10th root of x to the power of 4 y power 16. So this is like a horrifying expression to see, but you will see by the end, as you go on applying all the rules, this will reduce to some beautiful expression, and which is very simple. You will be surprised to know that this expression, which looks deadly, is really simple after simplification and applying all the rules. So now, applying property number 1 of nth roots, I can distribute the roots, nth roots, to x and y terms individually. So that would give me 5th root of x cube times 5th root of y square times 10th root of x power 4 times 10th root of y power 16. This applying the definition of expressing nth root as a exponent of rational numbers, I can rewrite each term as x cube to the power of 1 over 5, y square to the power of 1 over 5, x to the power of 4 to the power of 1 over 10, and y power 16 to the power of 1 over 10. Applying the rules of exponents, you can multiply the powers here. So that would give me x to the power of 3 by 5, y to the power of 2 by 5, x to the power of 4 by 10, y to the power of 16 by 10. Now you can observe the bases are same, so you can add the powers again applying the one of the rules of exponents. So, and we know that real numbers are associative under multiplication operation, so you can group like terms, and I will write it directly and add the powers. X to the power of 3 by 5 plus 4 by 10 times y to the power of 2 by 5 plus 16 by 10. So here you have fractions, you simplify the fractions, take LCM, so that would give me 6 plus 4, and this would give me y to the power of 10 and 4 plus 16. So this would be x to the power of 10 over 10 times y to the power of 20 over 10. So this is just xy square. So you can see this is so simple when compared to this horrifying looking expression. So all thanks to the rules and properties that we learned till now. Now I will give you a quiz. 1.1.5. Do the same thing that I did above. Simplify the expression and eliminate negative exponents to this expression. Now we shall learn about rationalizing the denominator. When there are radicals in the denominator of a fraction, so it becomes very difficult for simplifying an expression, especially when taking LCM and stuff. So we should write the fraction which has a radical in the denominator in a different form, so that the radical can be there in the numerator, but we eliminate the radical in the denominator by using certain operations. So this process is called as rationalizing the denominator. That is, eliminating a radical in the denominator of a fraction by multiplying both numerator. So this is the method that you follow, numerator and denominator by an appropriate expression. This process is called as rationalizing the denominator. So for example, I consider very simple one first, 2 over square root of 3. So I should eliminate this, make it as a whole number. To do that, see, you can see the nth value, that is, if you write it as in this form, n's value is 2. So to apply property, n is even, so we need to apply property number 5. So to apply property number 5, I should make this a square. So that means I should make it 3 square. For that, I should be multiplying it by 3. But this has a root and this doesn't. So you cannot apply any property here. So to apply property number 1, that is square root of AB is equal to square root of A times square root of B, in this case, I should apply a square root to this. So now, and you should operate the same even to the numerator. So when you do this, this will reduce to 2 root 3 over square root of 3 square. So now you can apply property number 5. This would be nothing but absolute value of 3. As 3 is positive, it is nothing but 3 itself. So this would be the rationalized form of this expression. I will take a tougher example now. So that would be 8 over cube root of 5 square. So this looks little tough, more tough. Okay, so now you again the same strategy that we applied here, but here you can observe that you need to add, you need to make this power 2 into 3 to apply property number 4. Because n is odd here, we can apply property number 4 of nth roots. So to make this cube, so I will multiply the numerator and the denominator by 5. But again, there is nth root, so operations are not possible with a whole number and an nth root. So what I do is, I will apply the same nth root that was there in the denominator for both numerator and denominator. So this doesn't make a difference. Why? Because this is just a fraction which is equal to 1. So you are multiplying 1 to a number. That doesn't change the value of the number. This process is just helping us to write the given number in a better form for simplification. So this will give me 8 times cube root of 5 divided by cube root of 5 cube. So you can apply property number 4 to this. So that would give us just 5 and 8 cube root of 5 over 5. So this is your final answer or rationalized form. So now your quiz 1.1.1.6. So rationalize the denominator. A divided by 6th root of BQ. So we completed section 1.2 of the book, which is exponents and radicals. We will move for 1.3. I'm not really sure like how far. I know that my progress is not like little bit slow for the first week, but I will patch it up. And please solve all the quiz problems as you watch the videos. I have embedded, or I'm giving out the quiz questions in the video so that you watch them. And let us meet for the office hours on Tuesday, because there will be no office hour on Monday. And let us meet. I want to give you some time to watch the videos as well as go through the syllabus or read the book. And if you have any doubts, or if you want to discuss the quiz problems or some extra problems that have not been assigned as homeworks and you still have trouble working them out, you can come to the office hours which starts from Tuesday. And do let me know if you have any problems. I'm always open to discussions. You can email me or set up an appointment so that I can go in a private Zoom session with you if you have any discussion to make which you are like really not comfortable to do it in the study hours. Thank you.